Hello, I'm DevPoodle. Today I'll be showing you how to procedurally generate meshes in Godot. We'll be looking at how to generate a plane, how to generate a cube, and how to generate a sphere. And by the end, you should have a pretty good idea of how these work and how you could expand it to other objects as well. So to begin, I have just a completely empty scene here. We're going to add in a mesh instance. Then we're going to add a script to this mesh instance, which we'll just call proc mesh. We need to make this script a tool script. Then we're going to create a new array mesh variable. So this is going to be an array mesh. For now, it's going to be empty. And for convenience, we're going to create a reload variable. So basically, this is just going to be an export. We'll call it reload. It's going to be false by default, and we're going to create a new set. So set new reload. And then we just do reload equals false. And then we'll call some like regenerate mesh function. So we'll need to specify this regenerate mesh function later. Basically, what this will allow us to do is just click this reload checkbox in the top right corner, and it will regenerate the mesh each time, so we don't have to like reload Godot or anything like that. So now let's create the ready function. This ready function is going to call the regenerate mesh function. All right, now let's define the regenerate mesh function. It's not going to take any inputs or outputs. First, it's going to see if the array mesh doesn't exist. If it doesn't exist, then we want to just assign it to a new array mesh. Then we want to assign the mesh of this mesh instance to the array mesh. So after we've made sure it exists, we're going to create a new variable called surface array. You don't have to worry about what this is quite yet. It's going to be an array. Actually, let's just say it's going to be the output of some create triangle function. We obviously haven't specified this yet, but we will do that right after this. So next we'll just call array mesh dot add surface from arrays, and then we want mesh dot primitive triangles. The array is going to be the surface array, and I believe that's it. And actually before this, let's call array mesh dot clear surfaces. This way, every time you regenerate it, it won't like add to the previous meshes. It will just like completely reset it. So now we need to specify the create triangle function. This isn't going to take in any inputs, and it's going to output an array. First thing we're going to do is create a surface array variable. That's just going to be an empty array for now. We're going to resize it so that's the size of mesh.array max. Then what we're going to do is create 3 other arrays. So first of all, we're going to have positions. This is going to be a vector 3 array. We're going to have normals. This is going to contain the direction that each vertex is facing. So let's create a packed vector 3 array. And then finally indices. And it's going to be a packed int32 array. Let's see a small graphic showing how this works. All right, so first we're going to specify an array of positions. So let's refer to them as A, B, and C. These are going to be vectors that give us the coordinates of each vertex. Then we're going to specify an array of indices, and what this essentially is going to do is going to tell us how to use these positions to form triangles. In this case, we're going to have triangle ABC that connects the points A, B, and C. So this is the way you'd specify a very basic triangle. And then you'd also have normals on each of the vertices, just telling them what direction they're facing. So in this case, all of them would be facing towards us because the triangle is facing towards us. All right, now that we understand how it works, let's actually specify positions, normals, and indices. So positions is going to contain 3 points, vector 3, 0, 0, 0, vector 3, 1, 0, 0, and finally vector 3, 1, 0, 1. These positions are essentially going to be like the bottom left corner of a triangle, the top left corner, and then the top right corner. It's where it's like a right triangle at the top left. Next, we're going to specify normals. These are all just going to be vector 3.up because this triangle is going to be facing up. So we can just copy and paste that a couple of times. And finally, we have indices. And as you saw before, we need to specify how the points are connected. So we're going to connect the first, second, and third point to form a triangle. Next, we need to pass these arrays to the surface array. So we're going to do that by setting surface array, and then the index is going to be mesh, and then the array we want to set. So in this case, like array vertex, and then we set this to positions. Then we do a very similar thing for normals. Mesh.array normal is going to be the normal array. And then we do almost the exact same thing for indices as well. Array index. Oh, and let's add an S over there. All right, now that we've mapped all of these subarrays to the surface array, we can just return the surface array. And now this function doesn't contain any errors. I believe what I'm going to have to do is reset Godot so that the tool script actually reloads, so I'll see you after the reset. All right, so we're back from the reload, and as you can see, it automatically regenerated the mesh. So as you can see, it's a triangle facing upwards, and you can tell it's facing upwards because if we look at it from the bottom, you can see right through it. So a triangle is not too useful, so next we'll get into something that you're far more likely to want, which is a plane. So let's go to the script, and we're actually just going to override the create triangle function for this. Change that to create plane, and then change this as well. Now let's see a small demonstration of how we're going to create the plane. So let's expand the demo we had before to a plane. So we have 4 positions this time, A, B, C, and D. And the indices are going to be a little bit different. Now we have 2 sets of indices. First of all, we have A, B, and C. This forms a triangle ABC. And second, we have the points A, C, and D. And this forms a triangle ACD. Although it forms 2 triangles, if we look at the outline, what we're forming is actually just a plane. And this is the way most game engines render planes. It's just as 2 triangles connected together. All right, now that we've seen how we're going to do this, let's actually change the code. Let's go vector 3. We have 3 of the corners here. We need the 4th one, which looks like it's going to be 0, 0, 1. For the normals, it's going to be an upward facing plane, so we can just copy and paste that. And then for the indices, as you saw in the demonstration, we're going to need to double the amount of indices because we want 2 triangles. So we have one connecting the 0th first and second point. So now we want one connecting the 0th, second, and third point. So it's going to be 0, 2, 3. All right, let's press reload and see if it works. Good, it works. So now we won't have to, restart Godot every time we want to reload it. We can just press this reload button. What I want to show you is if we go up here to perspective and then these 3 dots, we have a bunch of display modes. Now we're on normal. Let's go to wireframe. What this does is it shows us the borders of the triangles we're drawing. So as you can see, this plane is split up into 2 triangles, just like we showed in the demonstration. Now, most of the time, we don't want a plane that's just 2 triangles. Normally, we want to subdivide it into multiple subplanes. That way, we can do stuff like generate terrain on top of it, or do shader effects like having different parts of the plane move up and down like it's water. So in order to do that, we need to be able to subdivide the plane, which is what we'll do next. So let's create a new export real quick, because we're actually going to be using this for all of the later meshes as well. So let's just call it Subdivisions. Let's actually make this a range. I'm thinking we'll go from 1 to maybe 32. That should be enough. It's going to start out by default at 1, and then we'll create a new set. So set new subdivisions, and then we'll just set subdivisions to the new value, and then call regenerate mesh. Next, we need to actually implement subdivisions into these functions. So we're going to pass in subdivisions into the create plane function. So let's just call it subdiv in here, and it's going to be an integer. Now what we're going to do is we're essentially just going to loop over and keep adding new positions and normals and indices until we have all the vertices and triangles we need. So let's create a for loop. So for x in subdiv, and then for y in subdiv. We essentially want to do all of this. And it looks like it has messed up my indenting. Is that correct? Yep, looks like it. So one major difference is we're not going to be doing equals, we're actually going to be doing append. So dot append array, and then we're passing in this array. And we're going to do the exact same change to all the other ones as well. So let's just copy and paste this part. Then add a clothing parentheses, and then do the exact same thing over here. This way, every time we loop, we'll be adding in new vertices and normals and indices. So now we're going to create 2 variables in here. I'll call the first one vertex offset. what this is going to be a vector 3 dot right times x plus vector 3 dot forward times y. If you think about how this is working before, we're essentially going to add this vertex offset to each of these. That way, in every single subdivision, it will either move one to the right than a previous plane or move one forward than a previous plane. That way, we're not just like redrawing a bunch of planes in the same positions. So let's actually expand out this array so that it's taking up more vertical space. It'll just be slightly easier to see that way. So let's add all these vertex offsets. Let's just copy and paste this and then do that. So now all our positions should be working and all our normals should be the same as well, at least for now. One problem though is indices. As you can see, we keep appending the same two triangles, right? So it's just going to be using the first 4 positions that do in the very first loop, and it's going to keep doing those same triangles over and over again, which is not what we want. We want to use all these new vertices we're adding. In order to do that, we're going to have to offset the indices every time we loop. As you can probably see, if the maximum here is 3, we're going to have to offset it by 4 every single time we do a new loop. So let's create a new variable called index offset. That is going to be 4, and then x times subdivisions, or I guess times subdiv, plus y. So as you can see, every time it increments y, it's going to increase by 4. And every time it loops back around, it increases by x and then increases by, if we had subdiv at 4, for example, it's going to increase by 16. Now we just need to add this index offset to all of these. So let's place those, add it to there, add it to there, and there. Here, let's click this reload button, or this reset button. And now if we click reload, and we go to here, we should get just the default thing, but if we increase the amount of subdivisions, as you can see, it's extended it. So now it's one big plane that's subdivided into 4 little planes, each of which is 2 triangles. And so as you can see, we can keep increasing it, and it keeps expanding out here like this direction. Obviously, we want it to change in size as we're expanding it, but we'll get into that a little bit later, because that's actually going to be an important part of our next function. Let's go into script. Now we're going to copy and paste this plane function, and we're going to create the create cube function. Now, what you don't want to do is delete the create plane function. That actually is going to be incredibly important in how we create the cube. So let's rename the create cube, and let's also replace this part up here to create cube. So now if we scroll down here, we don't want basically this entire loop. So let's get rid of that. Now what I'm going to do is I'm going to create a constant array that I'm going to call directions. This is going to be an array of vector 3s. And it's basically going to have all the all the main directions. So we're going to have up, and then we're going to have 6 directions. So up, down, left, right, forward, and back. Then essentially what we're going to do is loop over all of the directions in this array, and for each direction we're going to create a new plane, and then we're essentially just going to stitch them together into one mesh. So if you think about that, we'll have 6 different planes all facing different directions, and then when we stitch them together, we'll just get a cube. And we can subdivide that cube, because we can subdivide each individual plane. And subdividing the cube is also very helpful when you're trying to, do shaders on the cube, or trying to do more interesting visual effects with it. So let's loop over all the directions. So we'll do for I in directions.size. So we're going to create a new plane in each of these. So let's do create plane, and we'll pass in the subdiv from this. And then we'll take our positions that we have in this cube function and append whatever's in the plane. So plane, and then mesh dot vertex, array vertex. So we're basically just using the same things that are up here, or down here, I guess. So we want to append the array that is in plane for vertex, for vertices. So it's actually going to be append array rather than just append. And then we're going to do the exact same thing for all the other ones. So normals, indices, and then array normal, and array index. So you might notice a problem here, which is we're creating a bunch of positions, but we're using the same arrays, right? Because we're calling the create plane function over and over again, but it's going to be doing the same index offsets. So effectively, we're just going to keep redrawing the same plane. In order to change this, we're going to have to add in a new parameter to create plane that we'll call index offset. Oh, sorry, let's actually just call it, let's just call it index. And it's going to be an int. Then we're just going to add this index to the index offset we already have. So now, as long as every time we create plane, we pass in a larger index, it should work. So here we're going to have to specify what index is. So let's just call it index. This is going to be 4 times I times subdivisions squared. So let's just do times subdiv times subdiv. Because if you think about it, every time we create plane, we're creating 4 points per subdivision in each direction. And then we're doing that 6 times for each direction. So 4 times I times subdivision squared. And then we pass in this index into plane. And now what we'll have is we'll have 6 different planes, but right now these planes are all layered on top of each other, right? We're not passing in the direction in any way. So next thing we need to do is pass in a direction. So we're going to add in another parameter to create plane that we'll call direction. It's going to be a vector 2. Or sorry, a vector 3, because that's what we're passing in. Now before this loop, there's a couple things we want to do. First of all, let's set direction equal to direction.normalized. Now, as you can see in the create cube function, it's already normalized, but if we were to call this plane function elsewhere, we always want to make sure the direction is normalized. So this is just a little safety check. You could remove it if you want, but it's just a tad bit safer. All right, next under direction, we're going to create 2 new variables. The first one is going to be called binormal. This is going to have the same components as direction, but effectively shuffled. So we're going to start out with direction.z, then direction.x, then direction.y. The idea of this is that we want to create a vector that's 90 degrees to direction. So by like swizzling all the components, we're going to have something that's 90 degrees to the original vector. And then we're going to divide this by subdivisions. And the reason we're doing this is so that our plane doesn't increase in size as we increase subdivisions. Because right now, as you can see, it like slowly expands over to like the top right. And we don't want that. We want it to always remain centered. So what we're going to do is create another variable called tangent. And this is going to be binormal and then rotated by 90 degrees around direction. And then 90 degrees, so pi over 2. Now what binormal and tangent variables will allow us to do is they essentially give us 2 right angles from which we can like base the plane off of. So if we look down here at vertex offset, we're already kind of doing this, right? We're doing right and forward. These are 90 degrees to each other, but the thing is they're 90 degrees to vector 3.up as well. But if we want to have, for example, a plane facing right, we have to pick new vectors, right? Because we can't just keep expanding it to the right because that will, well, I mean, at that point, it would still be facing the same direction. So effectively, we just need to find new 90-degree vectors to replace these, which is what binormal and tangent are. So we can just replace this with binormal, and then we can replace this with tangent. Now, there's somewhere else we were using binormal and tangent, but it's less obvious, and that's down here. As you can see, we're not actually adding anything to this, but to these, we are effectively adding the binormal and tangent. So let's just get rid of this, first of all, because that was just unnecessary. And now everywhere we see this 1, 0, 0, we want to replace it with the tangent. So let's just tangent. And then here we have binormal plus tangent. So tangent plus binormal. And then here we just have a 1 in the z, so it's just going to be binormal. So the next thing we want to do is we want to actually create a new variable up here that's going to be called offset. This is basically going to be a global offset for everything here. This way we can keep the plane properly centered, because by dividing it by subdiv, we are making it at a constant scale, but it's not actually centered around the origin yet, so we just need to create an offset to do that. So it's going to be negative subdiv times binormal times tangent, and then divide that by 2. Sorry, binormal plus tangent. Okay, so effectively this is going to keep everything centered. So let's add the offset to vertex offset. Okay, now we just need to pass in direction into plane. So let's do direction, or sorry, directions, and then I. Okay, now if we reload, let's see what has appeared. As you can see, we now have 6 planes all facing in different directions. There's a small problem with this. Let's do display normal. And that is that we need to offset these, right? So for example, we have a plane facing this direction, it just needs to be offset by some amount. So we're just going to pass in a small offset and then offset it in each direction. So let's go back into here, scroll up, and we want to pass in a center, which is going to be a vector 3. And then this center is just going to add onto this offset. Now there's actually one last thing I forgot to do, and that's normals. Not all of our planes are going to be facing up. As you can see, some are facing right, some are facing left. They're facing basically all directions. So we need to actually specify this normal to just be direction, right? Instead of just up, we want it to be direction, 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 direction. Okay. Now we scroll down here, and finally we can pass in what the center of each plane is going to be, which is just going to be directions, I, and then over 2. All right, now if we reload this, we finally should have a proper cube. And as you can see, we have it, a cube. And the nice thing is, if we go back into wireframe, this is subdivided by default. And so we can just change the subdivisions variable, and we can get more precise or less precise cubes, depending on what we want and the types of effects we're going for. So next we're going to see how we can turn this cube into a sphere. And this is where the subdivisions is really important. Let's go back into the script. And we don't want to copy and paste the function this time. So let's just call it create sphere. It's also going to have subdiv and int, and it is going to return an array, but almost everything about the function is going to be different. This is actually going to be much simpler than both of the other functions. So we will create the surface array, but instead of creating it from scratch, we're just going to call the create cube function. And essentially what create sphere is going to be about is just making all the vertices line up with the sphere. So let's return surface array here. And basically what we need to do is loop through every vertex in the cube that we've created. So for I in surface array, and then mesh.array vertex, so that we can get the positions array that we created, dot size. We want to take the array at I, and let's call it vertex. And let's specify that's going to be a vector 3. Then what we'll do is copy this, paste, and this is going to be set to vertex.normalized. So by doing .normalized, we're making sure that all the vertices are 1 unit away from the origin, therefore having them lined up with a sphere. Now let's change the function up here to create sphere. Now let's reload. Now you shouldn't immediately see what the problem with this is, but if we go to here and do display normal, now it's fairly obvious. We haven't changed the normals, so effectively every single vertex here thinks it's facing the same direction, which is why it's all shaded the same. And this actually is kind of an interesting looking effect, but it's not really what we're going for, right? We're going for a smooth sphere. So we also have to change the normal of each vertex. So let's copy this, but instead of array vertex, we're going to do array normals. And of course, we have the same amount of normals as vertices, so these should all line up perfectly. Now, something else I'm going to do is I'm going to divide this by 2. The reason I'm doing this is so that it lines up with the cube better. And now if we reload this, it should work. So if we go here, as you can see, we have a perfectly smooth sphere. Now we can change the amount of subdivisions. As you can see, it dynamically updates, so we can get a more blocky sphere if we want. Let's go back to wireframe, and we can keep increasing stuff. All right, thanks for watching. Let's go back to normal. So today I showed you how to generate procedural meshes in Godot with subdivisions. I showed you how to make a couple different things, such as a plane, a cube, and a sphere. And hopefully you have a pretty good idea now of how procedural meshes work in Godot and just how they work in general, because there's a lot of similarities between this and how they work just in most programs. So I hope you found this helpful, and if you did, please let me know in the comments, because I really enjoy hearing that type of feedback. So I've been DevPoodle. I'll see you next time. Goodbye.